Okay, so this is an example motivating beta distribution. So, but I like to change the, sorry, this one should be alpha 1 because this is a shape parameter, so it's better to use alpha notation. And actually this one is, it can be anything like as long as they are the same. So suppose this is beta is the same story, but it'll cancel out anyway because we are going to compute the ratio. Anyway, so this is the result is that gamma 1 x1 is gamma distribution with shape parameter alpha 1, and x2 is another independent gamma distribution with different shape parameter, and two random variables are independent. Then the ratio, so x1 divided by x1 plus x2, so they have the same shape parameter. Important thing is they have the same shape parameter. The ratio should be between 0 and 1, right? Because x1 takes positive value and x2 take positive value, and so the x1 y should be somewhere between 0 and 1, and its PDF is actually has this form. So this one should be alpha 1, alpha 2, alpha 1, alpha 2, something like that, right? So this one should be alpha 1 plus alpha 2. So I'm going to derive this one, and so proof. So so first consider a transformation. So y and z. So the mapping x1, x2 to y and z, right? Which is x1 divided by x1 plus x2, and this one is x1 plus x2. So that, and then we need to compute the inverse transform y and z to, so that x1 should be y times z, right? And so basically we want to compute the x1 and x2 in terms of the y and z. So that is y and z, and another this one is z minus y and z, right? Z minus x1. So that is this one. So Jacobian y and w, y and z is z y minus z 1 minus y, right? So that is z y z plus y z. So that is z. Okay. So that is 1 to 1. So 1 to 1 from A is x1, x2, which is positive, to B is y and z, and that is positive, something like that. Okay, so so we can use the formula theorem. Joint PDF of x and x2 is what? Is independence. So that is just alpha 1, alpha 2 over x1, alpha 1 minus 1, x2, alpha 2 minus 1, e minus x1, right? Because beta is 1. So that is the PDF. So then we can use the formula y and z Okay, so that involves y z alpha minus 1, right? X to z y z alpha minus 2 alpha 2 minus 1, and then e minus z, right? And then z, something like that. And so that is the PDF. So if you write it this way, alpha 1 plus alpha 2, so we want to factorize joint, so we want to express the joint distribution into a product of two component. So first component is, okay, so to be rigorous, we should write it as a I 0 to 1 y times I 0 to infinity c, right? So then we can write 1 minus y alpha 2 minus 1 I 0 times 1 y times gamma 1 plus gamma 2 u z alpha 1 plus alpha 2 minus 1 e minus z and z, right? Times sorry, okay, minus 1, so z is no longer here because minus 1 times minus 1, we have the alpha 2 minus 1 and e minus 2 times I 0 infinity c, okay? So once you write this way, you can recognize that this one is a PDF of y, and this one is a PDF of z, and this one is actually gamma alpha plus 2, alpha 1 plus alpha 2 and 1, right? So that that proves that derives this PDF. Okay. So that is the so because this is important, and we have a name, that is the beta distribution. I'm sorry. What happened? Oh no. Okay, beta distribution. That is this one. Okay, and the mean. See, so this one is what? Originally. Okay, the mean and variances can be derived, can be obtained. Something like that. Well, I'm not sure whether I'm going to prove it, but at least I can derive. Okay, I can derive one. So Z1 is gamma alpha 1, Z2 is gamma beta 1, and G1 and G2 independent. So well, maybe you can write this way: Z1 is Z1 over Z1 plus Z2 times Z1 plus G2, right? And then the previous theorem says that these two are independent. So actually these two are independent. So Z1 plus, which is X, which is this one, right? So So because we call it x, and these two are independent, so that means we have ex times e c1 plus c2. So that means this one is alpha and this one is alpha plus beta. So this one is alpha divided by alpha 1 plus beta. So that we can prove it. Well, this one is a little more complicated, with involves computing the second moment, but you can try. Maybe I can give a homework. So the beta distribution is useful in modeling a continuous random variable between 0 and 1, and with different parameter values. Well, if you notice, one thing you notice is that if alpha and beta are all equal to 1, then it is actually all these things disappears, right? So it's just constant. So it's called uniform 0-1 distribution. Dirichlet distribution is a generalization of the so k-dimensional generalization of beta distribution. So k equal 2 is simply beta distribution. So you can check on this. I'm gonna just give how it is derived. Okay, so x1 to xn, xk be an independent random variable with independent, and each one is gamma distribution, and so with a same shape parameter. So then the ratio it becomes there is something like correlated. So they are correlated, and some of these. So what is one interesting part is that some of these k are right. I equal to 1 to k is equal to 1 because of the definition. So this is the Dirichlet distribution, and the PDF. So we just derive. We are going to derive the this PDF using the same idea. Same. So I wrote the proof. So this is the joint PDF of xk, right? x1 to xk, and then find the transformation. So that so u is the x1 to xn k to y1 to yk minus 1 times c. And so that Jacobian is this one. You can check on that. So inverse transformation is easy to derive. This Jacobian is not difficult. The only thing is that if you why this is determinant is this one. Well, we can notice that this one. So if you consider some of the you can notice that actually the determinant of this guy is equal to the determinant of c. So you can see that the sum of this is equal to this one, right? And sum of this is equal to this, and then you just take the 0 and 1. Okay, yk minus 1. So the determinant is this one, and this is all 0 here, right? So then determinant is simply the product of the diagonal element of this matrix. So that's why we have this one. And then everything should be straightforward once you compute the determinant, Jacobian determinant, and after do some algebra, you can derive this PDF. So you can check on that.